Hi everyone, welcome to our lesson on graphing factorable polynomial functions. Remember, our polynomial functions are our expressions that have many terms. They can be degree 2, 3, or even higher. And so when we can see them in factor form, which means the groups of parentheses showing our factors, we will actually be able to also see the zeros, and therefore we can start there in our graph and possibly test some other points to get a good picture. So I'm going to talk about the things that we need to look at first when we're trying to get a good graph of these. First of all, when you can see factor form, like I said, you can see the zeros. So where are those zeros? You want to list those out. And then you want to look at how many times each one occurs. Now the occurrences of the zeros are going to be able to be seen in the degree of each factor. So for instance, if I have a factor in the expression that's x plus 3 to the fifth, that means that that zero of -3 occurs 5 times. So again, maybe something like x minus 2 and no power, that means that zero occurs once. So you want to look at the power on each factor to see how many of those zeros occur. Alright, and then you want to take a look at which ones cross the x-axis, which ones actually go through, and which ones just simply bounce off of it. Still touching, but bouncing off in the other direction. And the way you're going to tell that is by the power as well. Taking a look at these same ones here, if you have an even power, then that particular zero is going to just touch the x-axis and bounce right back off in that same direction that it came from. But if you have an odd power, then that zero is going to cross through. So taking a look at these, this one here, if I saw that one, it is odd, it's the power of 1, so that one would cross through. So is this one, okay, the power of 5. But if I saw something with a power of 2 or 4 or 6, those are just going to bounce. So we'll see what that looks like on the picture in just a second. First example, let's say we're taking a look at this polynomial and we need to get a graph, we need to get a picture. So remember our questions to consider. We want to take a look at where are the zeros, how many times does each one occur, and do they cross or bounce. Another thing as you're scanning through the original polynomial is to look at degree of the entire thing, because that's what's going to tell you if you got your picture correct when you're done. Meaning, are the ends doing what they're supposed to be doing? Our polynomial here is a degree 4, because each of these first two expressions has a degree of 1 and the last one has a degree of 2. And if you add those together, you're going to get 4. So think about the end behavior of a power of 4 polynomial. That is even and it's positive. There's no negative sign hanging out in the front. So the ends should both be up. I should be having an up, up end behavior. So we're going to remember that and make sure our picture looks like that when we're finished. Alright, so what are the zeros in this polynomial? So if I set each one of these expressions equal to 0 and solved, I would get 3, -2, and +1. Alright, how many times do they occur? And we're going to look at the power on each expression for that. So the 3 occurs once, the -2 is another power of 1, but the 1 occurs twice. So that is a double root, that's what those are called. Okay, and which ones of these cross and which ones are going to bounce off of the x-axis? Going to look at the powers on each expression. An odd power is going to go through, it's going to cross, an even power is going to bounce. So these first two are going to, let's just do C or B for cross or bounce. The first two are going to cross, and the last one's got an even power, so it's going to bounce. So we've done our homework, and now we're ready to do our picture. Alright, so remember our zeros were 3, -2, and 1. So let's start there on our graph. Let's go out to 3, -2. Let me fix that. Out to -2 and +1. Alright, and we have a degree 4, and remember that our first zero over here, our -2, was a cross-through zero. So starting up, because we know that end is going to be up, we're going to cross through. Okay? At our next 0, that one was a bounce. It had a power of that was even. So I don't really know how far this graph is going to go down before it comes back up to this 0 to touch. But if we wanted to know that, we would test some numbers in between here to see just how far it goes down before it reaches this next 0. But I do know it's going to get back to it. It's going to bounce. And then bounce right back off in that direction and eventually come back to our third 0 and cross through again. So just knowing those things can give us a really good general picture. And if we want to know particulars, we'll go test some numbers into the polynomial and find the matching y's. All right, next example. Let's take a look at one more. So we have a polynomial of degree 5 this time because we've got 4 here and a 1 here, which gives us 5 when added together. So what is the end behavior going to be like for a polynomial of degree 5 that's odd, that's positive? Something like that. We don't know what it's going to do in the middle yet, but we do know that we have an end behavior of down on the left end and up on the right end. So let's remember that when we get our picture. Okay, so what are our zeros? Well, we have each one of these set equal to 0 would give us -2 and +1. How many times do they occur? It looks like this first one, -2, occurs 4 times. And this second one occurs only once. A little something about that. And now which ones are going to cross or bounce? Remember, the even powers are going to bounce. So our -2, 0 is bouncing off the x-axis. And our 1 is a power that's odd, so it's crossing. All right, so let's remember these characteristics as we go take a look at the graph. So -2 and +1 are our zeros. We're going to start there. And remember, our -2 was the bouncing 0, and our second one was the crossing. Our end behavior supposed to be down and then up. So we're coming in from the bottom here. And we are going to bounce off this 0. Going to go down some amount, we're not sure unless we test points there, but eventually it's going to come back and cross through the second location and continue up forever. Okay, and I will make one more note that the higher the power on your 0 or your factor, the wider the graph will be at that location. So remember, this 0 over here, this -2 had a power of 4, so it's probably pretty wide as it bounces off, and the higher the wider it gets there. And this concludes our lesson on graphing factorable polynomial functions.